Good day and welcome to the Math Salon. My name is Dr. Nimandem. So for those of you who are new to the Math Salon, know the Math Salon is a place for everyone. Most especially for students who want to learn, who want to get something new, who want to improve their mathematical skills, who want to learn beyond just passing exams, who want to understand the basic concepts of mathematics they do every day. So we had a quiz last week. So first I will start by thanking all of you who participated in the quiz. It takes courage to do that, and I really appreciate it. And I also pray that you would, of course, learn from this, because that's the intention. I have no other intention than to help you to improve in your mathematical skills, be better prepared for your exams, and be a better person in the future. So this quiz, we had one for the ordinary levels and one for the advanced level. The solutions that I will give you today are not but just possible solutions. There could be many other ways of solving them, and that is also welcome. What is important is that you make sure you follow the mathematical principles and basic concepts. To better understand the solutions and grasp its content, it's best that you first watch the videos of the quiz itself. Otherwise, you won't really understand, or you won't gain much by just looking at these solutions. If you watch the video, you try them yourself before you watch the solutions, I assure you, you would be a better person after. So we start with the ordinary level quiz. So the first question was a question that was to test the students' idea about factorization. Factorization. The difference of two squares is one peculiar technique, skill, that comes in different ways. You would meet them in mathematics and chemistry and biology. You will find them one way or the other, where you require you to remember something. But if you actually do understand it, it will take a long time for it to disappear. It will always sit at your subconscious. So in order to do this, you had this expression that was given and you had to simplify it to one of the possible answers. So to do that, I have to look at those factors and try to recognize the ones that for me can look like a difference of two squares. Consider you also told that a squared was equal to b squared plus c squared. So if I take a plus b plus c and the last one b plus c minus a, then I can actually write the first one as b plus c plus a and b plus c minus a, and the two can be together as the one you see here. And then I see here, if I factorize this, I get these two factors. So if I multiply this out, I should come up with that. I could also recognize the second and the third factor in a similar way, also rearrange them. So this is a plus b minus c. So I will say no, I have a plus, I put b minus c as 1. But you see here, this is not b minus a, it is c minus b. So I can introduce a minus here and change the other. So it's like factorizing minus 1 out. If I do that, then I get a nice form that you see there. And then I can recognize again, this is a difference of two squares, and it can be written like this. This can be expanded, that can be expanded. If I do expand, I get b squared plus c squared plus 2bc for this. But then quickly recognize that's given a squared is equal to b squared plus c squared. I can do this. And then this is a squared and it cancels with that. And I get the square root of 2bc. Can apply a similar technique here. Replace b squared plus c squared with a squared. Open up my brackets so that this minus becomes minus a squared. So the fall off and this becomes plus. And I get again the square root of 2bc. It was a product of all of them, so I put them, I just split here to ease my work. So I put them back and then I get this squared. So it's multiplied by itself, so you get just 2bc. And the answer for that was B. For question number 2, you are given a figure. This question has come already in previous quizzes. Even the first one has already been there. So in order to solve this, we have to look for this area, both the dotted and the shaded one. So I will start by looking for the shaded one and then just multiply by 2 because it's symmetric. So to do that, to look for the area of the dotted region, I think I should look for the area of the sector A, B, C, D, this sector, and I subtract the area of the triangle A, B, C from it. If I do that, then I get the dotted area and I can just multiply by 2 because it's symmetric. And that's exactly what we will do here. First, we look for the area of the triangle. There's a half base times height. The base is 5, the height is 5, or however you take it. And then the area of the sector, if you look at that sector, is just 1/4 of a circle. So that's just like 1/4 of the circle of radius 5 centimeters. If you do that, that is pi 1/4 pi radius squared. You get this expression, and then you take the difference and multiply by 2. And you see the answer was C. For question number 3, you were asked to look for the possible values of x given that these two are the same. And the truth is, yeah, if you have two like this, if this squared is equal to minus that squared, then the only way that is possible if this value inside is 0, it's only 0 that is equal to minus 0. No other number can have that property. So in that case, it's just solving for this equal to 0 and also that this is equal to 0. If you solve for this properly, these are simple factors, these are simple quadratic equations. Then x equal to 5 and x equal to minus 1. At the same time, we should have x equal to 2, x equal to 1. There's no possibility there. All the x's are all different, so none of these satisfy that condition. So these two expressions based on that equation is not possible. So we look at question number 4. This was to remind you again about, equation of straight lines. So if you look at the gradient, and then you look at the equation of a line given 1 point and a gradient. If you are given 2 points, the equation of a line given 2 points is just y minus y1 is equal to y2 minus y1 divided by x2 minus x1 multiplied by x minus x1. But yeah, you don't need to always do that. You could also just look for the gradient using this small piece. I can split it. If you do that, one key thing would have been, I gave the equations with decimals, the coordinates were in decimals, but it would have been much easier if you change them to fractions. So I did that here. And you get a gradient of minus 1/4. Then I can look for the equation of my line using my formula and I plug them in. If you simplify that properly, you get 8y plus 2x minus 1 is equal to 0. And that was D. Then question number 5 was for you to look for the possible, how many factors this has. Again, it's the idea of difference of two squares here, but you have to fix it to look like difference of two squares. So I know that the delta to the 16p is the same as delta to the 8p all that squared. And gamma to the 16q is the same as gamma to the 8q all that squared. Because a to the m all that to the n is a to the mn. So the powers just multiply themselves. So the power of a power is just the product of the powers. If I do that, then I can split this as a difference of two squares. Then simply delta is 8p minus gamma 8q times delta 8p plus gamma 8q. The minus part again has again property of difference of two squares. I split it down. And again, this again some other property and I split it down. And if you did that, till this level, you won't be able to split anymore to real factors. So what you end here then is there, you get 1, 2, 3, 4, 5. So there were five factors for this. So we go to question number 6 there. So if you did that well, that was A. Question number 5, the answer was A. It seems I've cut out during my scanning. So for question number 6, this question is the one that I made some small adjustments because it seemed that the answers I tried to swap them and made a small error there. Sorry about that, but it has been taken care of. So the sum of the squares is equal to the quadruple of their product. So if I get two numbers a and b, and that the sum of their squares is equal to the quadruple of their product, then it means a squared plus b squared is equal to 4ab. You are asked to look for this ratio. So the key thing here is simply to look for a minus b, a plus b, and then you do that. But what I have here as information is in squares of this a and b. So one key way is to try to square this, and that's what I did here. If I square this, I get this, and I can write it in this form. And see and recognize at once that I have a squared plus b squared, which I can replace with 4a. I do a similar thing to this, I get that. And when you fix them out, you get 2a and 2ab and 6ab. If you divide them, you get 216, and that's 1/3. But this is the ratio of their squares. This is the ratio of a minus b squared, a plus b squared. You were asked without the square, so you have to take the square root of both sides. So if I take the square root now, I get 1 over root 3. But this is not in surd form, so you have to play with this by multiplying top and bottom by root 3 to get root 3 on 3. So for question number 7, that was also beautiful, and that was the only question that was new as far as this was concerned. You were asked to express this in the form a into x minus alpha squared plus beta. To do that, you just need to try to complete the square. Completing the square is one of the most popular techniques in solving quadratic equations. It is the key that is used also to derive the general quadratic equation formula. So it's something that you also really have to master. Then you don't have to cram so many things. You just have to remember the procedure. What do you do to complete a square? So to complete a square, one of the key things to do is first try to make the coefficient x squared 1. How do I do that? I just factorize 3 on 2 outside the bracket. So here I'm left with 1. But here, since 3 on 2 was not there, it's just like auto force 2 on 3 here. So if I force 2 on 3, 3 cancels 3 and I'm left only with 2. And I can also force 2 on 3 here. 3 cancels here, 4 times that is 8. So this is a nice form. Now inside here I should complete the square of the inside quadratic equation. To complete the square, we simply take half the coefficient of your middle term, square it and add, and then subtract because we did not have it. We cannot add to that equation. If we add, then it's not an equation except we subtract it. Then our equation stays valid. So I took half the coefficient of minus 2, that's minus 1. I square it and add to the remaining part of my work. But I have to remove it as well because it was not given to me. So if I add and remove, then nothing has changed. So it just becomes beautiful. That's the idea of the math salon, to make mathematics beautiful. So if I do that here, then I can now say, oh, I can have completed the square of this, and this is x minus 1, all that squared. Minus 1 squared is 1, minus 1 is minus 1, plus 8 is 7. Can open this bracket so it looks in the form I was asked to. So that's 3 on 2 into x minus 1 squared plus 21 over 2. Some alpha here is 1 and beta is 21 on 2. If I sum them, I get 23 on 2. Note that each time when I ask you to give me the solutions to the sum and things like that, it's because I don't just want you to put into a calculator or take the answers that I've given you and you test into the equations. It is to make you do some work. Look for the solutions. Question number 8 has already been done as well. Please, I advise you, look at the Math Salon channel. Please, I already did that. So you are asked to look for this expression. I understand that you have calculators, but if you try to do this with a calculator, it's going to say error. So the key idea is to try to play around between your log and exponential because they help one another. So if I just let my y be equal to this and I take the log on both sides, then from properties of log, my 75 can fall in front. Then with your calculator, you can actually do log 36 to the base 10. If you do that, you get that expression when you multiply by 75. But then I was not asked for log of that, I was asked for that. So I will do the anti-log process. So you move back from log to the logarithm. So and that's simply the base raised to that. And you can play with this. 116.2723 is the same like 10 to the 116 plus 0.72 that. So I can actually write it in this form. And if you play with that, this was your answer, which was A. Question number 9, this is also very simple. Very simple. We've done this a number of times already within the Math Salon. Please watch those videos if you really want to understand mathematics and grasp basic concepts. And that is D here. For question number 10, D is also very simple. I took it from one of the GC questions as well, some long time. So this is something that was just for you to be able to simplify. Play with the exponents. Apply the properties. Apply your basic ideas. And then that would be C. So we've come to the end of the O-level solutions. Thank you for your participation again. And please, before you take part in any quiz, try to make sure that you go to the Math Salon YouTube channel, check through all the solutions that are there. Then you'll be better prepared, not only for the quiz, but then you would be knowledgeable also for your class exams and other exams that you may be involved in. Thank you.